Good morning. We're going to start talking about some Calc 1 material actually, and what I want to do is make sure that you eventually do say that I love substitution, because this is the technique that you're going to learn to like if you don't like it already. So like I always try to do, I try to set up and identify steps for what you're going to be doing. So you need to recognize that when you have two functions multiplied together, that your only option as of Calc 1 is to either, well, two options is to do algebra, where you distribute or square or do separate fractions, or you might do substitution. So the big thing is that you have to pick something that's going to be set equal to u. And when you do that, you need to make sure that you choose something that will give you a derivative that will be allowing you to use that for substitution reasons. So the thing you'll hear me say, and some of you have already heard it in Calc 1, is whatever you let u to be equal to, you need to anticipate its derivative. So if it doesn't give you something that you can use to substitute to get rid of other parts of your product of two functions, then you probably have chosen poorly. Now here are some guidelines this way of things that you can use, and this is not set in stone, but this is just some suggestions. If you have the big 6 and your angle is something other than x, you need to use the u equal to whatever the argument is. So like if it's sine of 6x, you need to let u be equal to 6x. Another one is the larger degree. I don't know if that's a real word or not, but we're going to use it. The polynomial that has the larger degree. Okay, something else that I'd like you to think about and use, unlike maybe the book, and that is when you have an exponential function, that you let the u be equal to the exponential function. And I don't care whether it's u e to the x or some other number like 5 to the x. And there's a reason for that, and that mainly is that you don't forget the natural log of the base. And we talked about that in Calc 1, and I'm sure we'll talk about it here as well. And then last but not least, then, if you have an inverse trig function, if this is not just an x or a u by itself, you need to do substitution. Otherwise, you're going to mess up the coefficient. Okay, count a couple seconds, and I'm moving on to the next page. Now, once you've made those decisions, you have to take the derivative of whatever u is. Okay, so you got to take the derivative of whatever your substitution is. And then, as far as step 3, this is your choice. It's a matter of style. One way is not better than the other. So these are some suggestions. Again, you don't have to necessarily do it this way. So one is to solve for dx. The other one is to multiply both sides by a number so you can make it equal. So you can finish your substitution is only different because of the coefficient or the constant, multiple of the constant. You might want to factor. And then there's this thing I call creative substitution, where you solve for x in terms of u. This is going to be more on test 2, but I'll probably show you an example in the Zoom session at some point, just to make sure you're aware of whatever's we're talking about. Now, once you've done that, make sure there's only an integral in terms of u. You cannot have a mixture of variables. That is a no-no. There's no x's and u's mixed together. And so once you have that, then you can take the antiderivative or take the integral, and then you just simplify and resubstitute. Because when you do substitution, you always have to resubstitute. So I'll count a few seconds and then move to the next page if you want to write. Well, you do need to write it down for your notes. All right, so here we're going to start doing some examples, and I need a different color. So let's do this. If you look at the polynomials, you've got an x to the third minus 7. That has a higher degree than the 2x squared. So that means you need to let u be equal to the x to the third minus 7. When you take the derivative, we're going to just not mess with the implicit differentiation and do the derivative like you normally would have done, or you eventually normally do, and you'll get 3x squared dx. Now, the coefficients don't match, so you have an option here. One option is to just go ahead and get rid of the 3 by multiplying both sides by 1/3. So 1/3 du is equal to x squared dx. And here's where I'm going to go ahead and get my colors going here. So we have this part right here can be substituted for by this 1/3 du. So I'm going to have a 1/3. I'm going to have a du. I think I'll put it way over here to make sure I have enough room to keep the things that you know I'm not manipulating. Okay, the 2 is just going to be brought out here because I can do that with a constant. So the 1/3 du is going to go in place of what is circled in purple. What I circle in orange right here, that's going to be substituted with a u. So this actually, I don't need as much space as I made, but oh well. It's going to be u, and it's the 5th root of u squared. Let me bring that du over because I certainly don't need it that far over. Okay, so before I can take the antiderivative, I'm done with the colors. I've done the substitutions that I need to do. Everything's in terms of u. Let's just go back to black so I'm not driving you crazy with the clicking. And so you have 2/3, the integral of u to the 2/5 du. So you need to remember that information. Alright, next step then is for you to take the antiderivative. And if you're in my Calc 1 class, you know that you can do an easy addition of 1 by just adding the numerator and the denominators together. Just add these together. Alright, and something else that you probably need to get used to, because this is my style, and that is you'd have 2/3 u to the 7/5, and you have to divide by 7/5. Well, then go ahead and multiply by its reciprocal. So we're going to multiply by 5/7, and I'll wait on the plus c for just a moment. This is going to work out to be 10/21 u to the 7/5, but I have to resubstitute. So 10/21, and I would resubstitute. I have x cubed minus 7 to the 7/5 plus c. And there's your answer for this particular integral. Alright, so take a moment to look at that, stop it, copy it down. This will be in your notes that you need to turn in an example. Okay, so now we have another example, and again, it's based upon your guidance. We need to go ahead, it's one of our big 6, so we need to let u be equal to 1/2 x. So du is equal to 1/2 dx. I'd multiply both sides by 2. And I'm ready to do my substitution. So I would have 2 the integral of the cosecant of u, cotangent of u, du. So this integral is going to be a cosecant of u, and it would be a -2 because this is a reciprocal function. And then resubstitute. Let's try that c again. Cosecant of 1/2 x. Alright, so there's another example. Take a moment for you to copy things down. Okay, now here's another example of substitution. Again, you can look at the higher degreed polynomial, and so we should let u be equal to this x squared plus 2x plus 5. Du is equal to 2x plus 2 dx. And here's where you'd want to factor a 2 out of there. So we have to use the factoring strategy. And at this point then, if you want to get rid of the 2, again, this is your style, it doesn't matter how you do this, du is equal to x plus 1 dx. So again, time for colors. I can substitute this in place of the x plus 1 times dx. So this and this gets substituted for. Okay, so I can put a 1/2 du in place of that. And I won't go so far this time. Alright, then I also have, if I get the colors out, this function right here. I'm going to put a u in place of that. And if we go back to black, this is going to be 1/2 u to the 8th divided by 8, which is going to be 1/16. 1/16, and when I resubstitute x squared plus 2x plus 5 to the 8th power plus c. Give you a moment to do that. Copy that down. All right, another example. If I sound exasperated, my daughter's texting me while I'm trying to do this video. All right, so we're going to let u be equal to the natural log of x. This is anticipate the derivative comment. Okay, so du is equal to 1 over x dx. And there's really nothing to do to this. You can circle the things that are going to get substituted for. This and this get substituted for by a du. So that's gone. And so you have the integral of, and you'll have something to the 4th power. And if we use the other color, then the natural log of x gets substituted for by the u. So it's u to the 4th, and you take this antiderivative, it's going to be u to the 5th times 1/5, or 1/5 times the natural log of x to the 5th power plus the constant c. Alright, give you a moment to jot that down, but again, that's the anticipate the derivative comment that I made in the steps. Alright, now, this is your knowledge check. So I would like you, when you submit your notes, that you're going to answer these 2 questions. So if you look at number, or the A question, that integral, what would you let u be equal to if you're going to do substitution? That's it. Don't do anything else. Just tell me what you let u be equal to. And then do the same thing for question B, or part B. If you have sine of theta is equal to cosine theta to the 3rd power, what would you let u to be equal to in this situation? That would be the easiest thing to do. Alright, I'm going to count to 3, and then that's the end of this video. Told you they weren't going to be too long, if I can help it. Again, you need to submit the answers to these 2 things with your notes when you do that.